Welcome back to the channel. In this video, we're going to be going over making a 3D map that you can navigate through like you would a mini map, but in 3D. To start off, we'll go with a first person template. I'm going to leave it my project. If you want to call it something else, it's fine. Let's go and create. Once the project is loaded and the shaders have compiled, first thing we'll do is import some assets. So these assets are just two very simple ones that I made myself. We're going to create a folder for them. Well, we'll create a folder for the whole thing. We'll call this 3D map. Open it up, and we're going to make a new folder for our assets. So let's go and open that and import the map and the player asset that'll be in the Google Drive in the description. Import all. Save all. And there we go. So the next thing we want to do is we want to actually get a new level because this one can cause some issues. And so we go into File, New Level, Basic, Create. We Control S to save it once it's open. In our 3D map again, we'll just leave it as a new map. Okay. Now the next thing, first what we need is we need to update our first person template, I guess you could say, because currently it's using a first person character that we don't want to use. We want to make a new one. So we'll start with that. Right click, blueprint class, and we're looking for all classes and we're looking for the first person character. So select that, and it will be called FPS underscore 3D map. Well, it doesn't have to be in all caps. Let's just, there we go. So we can open that up. And before we do too much, we're going to also change our world settings here. We're going to take the game override and use the first person game mode. But we'll pull the drop down for selected game mode and select our actual pawn that we just made. So replace the first person character here with our FPS 3D map. So now that we do that, if we go and open this one here and we print, check that we have our new character. If we run it, we get a print because this is our new character that we just made. So for this character, we're only going to need the begin play because we're going to need to add some new inputs. So we'll make those new inputs first. So right click, go down to inputs, and we're looking for input mapping context, which we'll call IMC map. Now, some of this we'll be able to use the previous inputs like the movement and the panning for the camera because that's already set up in the player character. So we'll just be making the new ones for the actual map. So to do that, right click, input, we're looking for input action, and we're looking to call it IA map. Now this one we can leave by default, we don't need to do anything else with it. We're then going to need a few more. First one we'll call for zoom, and one for unzoom because we're going to be doing the zooming by using the right click and left click, so it's two different inputs. Then we need a input for focusing, so once again we can use the default class for this, so it's going to be focus. This is going to be middle mouse button. Then we want one for level up and level down, so up. As when we're panning, we can only do it in 2 dimensions, so we need a way to move down a level if we need. So, and this will be level down. Now, all of these use the default class, or the default state, meaning the value type is a Boolean. So we can just leave it as is. And we can save all of them with Control-Shift-S. Now we need to actually add them to our input mapping context. So the first one is going to be, well, the map. We'll just add that, search for it, add it here. We'll just use M to call that one. Next, we want the zoom in, and that's going to be left click. Then we want the zoom out, or unzoom, which will be the right click. The next one will be focus, which is going to be middle mouse. Then we want the levels. So levels will be, we'll say level up for Q and level down for E. So let's get that. There we go. So that's all our inputs done now. We just need to go and add them or add our mapping context to our player character. So to do that, right click, get player controller, and we're going to get the enhanced input local player system. And so with this, we drag this out, we say add mapping context, plug it in here, align it all up, and the mapping context we'll choose is our map. So to check if this is working, we can call the IA map, and make sure you use started and not triggered, because if we use triggered here, I'll show you what happens. If I press M, and if this is working correctly, it'll do it multiple times, and so that will cause a few issues. But if we do it on started, it'll only do it once we press it once. Even though I'm holding it now, it's only doing it the one time we click. So it's just to have one call instead of a tick of calls, let's say. So we know this is working, we have our inputs. So before being able to do anything with our inputs, we need to be able to create our map. So the first thing we'll do, we'll just leave IA map the only one there, because we're going to set up our map first and then spawn it in, and we'll make our functions to be called from the different inputs. So the first thing we need obviously is our actual actor. So let's actually put these in a folder, which we'll call inputs, because there's a lot of them. Move these all right into here, and we can right click blueprint, and we're looking for an actor. It's going to be a_map. Simple as that. Nothing too complicated. We can go and open it up so that we can test that it actually works. So inside of map, what we'll do first is we will just add our map. So we're going to add a static mesh. It's just so that we can visually see it. And the map is going to be, well, called map, and it's the asset that was in the actual Google Drive folder. So it should look like this. Now, with this in mind, what we'll have to do also is we're going to remove this, which is our default plane, and we're going to add our actual map, because the map needs to be representative of the actual whole world. So we get our asset here, and we drag it in and drop it here. Now make sure we set it to 0, 0, 0. And what we'll do is we will scale it up by 40. Now, I'll show you, because later we need to take this into account, the scale. So this is what it looks like, and if we play, I think we'll fall through the ground. Well, actually first we need to add our spawn. So let's do that. So start location, or player start, place it here. And yeah, so we have an issue because of the collision. So let's fix that. Right click on or left click on our map, select the static mesh itself, or we can open it here if we want. And the reason we have an issue is if we go and I think show simple collision, that's the problem. Currently these are the collisions that are being used. So to change that, we need to go into our details and look for collision, and we're going to look for collision complexity, and project default means like this, but what we want is we want to actually use the complex ones, and so the complex ones are really more precise and will do exactly to the shape of the object, even though they're more heavy. So be careful when using this, but in our case it's not too bad because it's not that heavy of an object. So change project default to use complex as simple. Then we can save, and if we open it now, we can move around and we actually do hit all the objects. So we can no longer fall through the floor, and there's no problem with the spawn normally. There we go. So next, with our map open, we have visually our map. Now one extra thing we can add while we're at it is we need to add our player. But to add our player, there's a little caveat we need to take into account, is we need a pivot point, because we need to know relative to the real world, or to the actual size here, where the player is relatively in the map. So to do that, we need a different anchor than the actual center of the object here, because obviously we know that's 0 and that's 0 here because it's the same pivot point. So we need a second point. So to do that, what we can do is we're going to select our player start, and we're going to search for tag. And what we'll call this, so here we want to, sorry, not there, but here in the actual actor tags, we're going to add an element which we will call spawn tag. And that's going to be our second anchor, so to speak. And it's what will allow us to set the player location correctly. So to do that, we need to add a second point in our map, very similar to that. And so that point is going to be called scene components. So make sure it's like this one. It's by default, it's just a point in space. Let's say it's like adding a target or similar to a target in the actual editor itself here. So actually we can close the map by itself. And so we'll rename this to what it is, which is a pivot. And then we'll add another static mesh. And this static mesh is going to be our, well, it's going to be our player. So we'll call it just that. So search for player here. And there we go. So now we have our player as well. Now that we have our map visible, let's say, we can, and actually existing, we can finally go and call it in here. So back inside of our player character, or our child of the player character, we need a variable, and that variable is going to be called as a map, and it's going to be of type a map. It's a reference to the actual map that we're making appear, just like with any pause menu or inventory. So we want to check whether it is valid. So if it's valid, we're going to delete it. If it's not valid, we will respawn it. There's one extra thing we need to do though, so we'll do that. As a map, if it's valid, we want to destroy actor. And what we'll do here in addition, because currently if we make it spawn, the movement of the panning of the camera would still use the movement, would still apply the movement for the character. So the character would move while we're looking at the map, which is a bit strange. So we'll have to disable that. So to solve that problem, we get our character movement here. And obviously we're doing the reverse here because we're destroying the actor. We're going to say set movement mode from none to walking, because we're going to call on spawn. We're going to say stop. No, it's not stop movement. It's disable movement. And this will mean the player can no longer move even when he presses the right inputs. So with that in mind, we can now do the is not valid, meaning we want to spawn it. And that's going to be a spawn actor from class. It's going to save itself in as map. So first we need to set its type to a map, plug it in, and then we can connect it to disable movement. Now currently it's going to spawn it's not going to spawn where we want it. So to do that, we need to place it in somewhat in front. So first we need to make a transform. So just the basic one, not a relative one. Just make transform. And for the location, we will get forward vector of the actor. We will multiply it by, let's say 75. We can change this type by doing right click convert pin. Put 75 here. Plug in the location, not plug in the location directly. We need to add it to our current location of the player, otherwise this will be in 0, 0. So we will get actor location. Drag this on, line it all up, and move it to the side. So now if we go and play, and if we press M, the map appears in front of us. And we can't move because we've disabled our input, so even if we're pressing here to move, it won't work. Press M again, it disappears, and we can move, no problem. So the next thing we need to do is we need to actually set up our map to, well, take our inputs. So before we add our inputs, we need to be able to do something with them. So I'm not going to add the inputs immediately. First, we'll make the functions for them. But the first thing we want to do, because currently if we move and we look like this, press M. Oh, sorry, that's the wrong button. If we press M, it appears like this, and we need to make sure that our camera in our actual map, because we're going to use a separate camera, sets itself to the same location as the player. So to do that, we are going to just pass a variable through. Actually, no, maybe we won't pass a variable through. We'll do this differently. So inside of a map, we need to add our actual camera first. So this camera is going to be attached to a spring arm, which we'll get right here. And we want to actually attach it to the default, not to the static mesh or anything. We just want it on the default route. Then we're going to add a camera. Just a basic camera right here will do. And the spring arm needs to be of length, I think it's 75, just to make sure. 75, and so it's rather short. And the camera itself, we just leave in 0, 0. We don't need to do anything there. And for the spring arm, we're going to be actually setting up its rotation, etc. at begin play, because that way we can tell it what to look like or what orientation to have. So in the construct script, what we need to do is we need to inform the actual camera, or more like we need to inform the player controller that the camera is going to change. So we'll do that right here. We'll say get player controller, and we will search for blend view or set view target with blend, attach it to be in play. And the new blend target is not the camera, it is just simply self. It'll recognize that there's a camera and it will attach them correctly or replace the camera. So let's compile and save. And if we do M now, our camera or player immediately teleports to where the camera is located. As if we just show it here. That's where the camera is, and that's the place where the player's current camera is, let's say. So because that looks weird, obviously, now it's in the middle, but even if it weren't, even if you were to set it at a location, the player might not always be aligned the same way. So we need to try to just move to that location, or the closest location possible. That way it looks as smooth as possible. If you wanted to, you could get the location of this camera and lerp the player camera to that location and then swap. But for simple sakes, we're just going to teleport it. Okay, so to do that, to make sure the camera focuses the right location, what we'll do is we will do this secondarily. So we won't do this first. What we'll do first is we'll do that movement. So we're going to get camera manager, which is a reference to the actual camera itself. We will say get actor location. And with that camera location, we're going to get our static mesh, which we'll rename to map, so we know what it is. We're going to get world location. And we're going to do something called get lookout rotation. So from our actor location here, we'll say get find look at rotation, and the target is the SM camera. And with this, we're going to set the rotation of our spring arm. So set world rotation, make sure you use world and not local, or relative, sorry. Line that up, connect the new rotation, and now we should have something a bit better. So if we go and press M, it does work. The rotation is correct now, it's just that distance-wise we're still very, very close to the actual camera, which is what's causing this kind of weird zoom, let's say. But we'll fix that in a second. The reason it looks so strange is because we actually need to disable something in the spring arm. We need to disable collision tests because we need to ignore the map as a target. And normally now, yeah, so now we have an actual moved back angle before we were actually hitting the player, which is causing it to say, well, hey, we can't go any further than this, so stay that close, which we don't want. So make sure in the map in the spring arm, we disable the do collision test. So now the next step is simply making our map move and function. So to do that, we'll make all our different functions first, and then we will apply them one by one to our different actual inputs. So we'll start with the zoom. So zoom in and a duplicate zoom out. So let's go with that. So very simply, what we want to do here is we'll get a reference to our spring arm. We will get our target arm length. And we're simply going to say, well, on zoom out, we will be reducing it. So we'll say -1. And this is a bit counterintuitive, but zoom out, or no, sorry. Zoom out is plus. So +1, and we need to make sure here, you don't have to do this, but in most cases it's better. We're going to clamp the actual float because we don't want the player to be able to zoom out infinitely or zoom in infinitely because it's a waste. So we'll put them in at 40 and the max at 100, and we will then get another reference to our spring arm and say set the target arm length. Apply that here, plug it into the zoom out, and we can actually just copy this for the zoom in and just replace it with a negative -1 instead. So let's just do that. Go -1 instead. By default it's 75, so that means we're already in this bracket, so we shouldn't have to worry. So to call those, we need to get our zoom and our unzoom. So once again, we only want to call these if our function is variable here, or if our variable here is valid. So on started, actually no, in this case we do want it to be on triggered because we actually want it to call multiple times. We want it to zoom in progressively. That's why it's +1. So here we'll say zoom in, and on the other one we will say zoom out. So now if we go and play, we should be able to zoom into the mesh, or zoom out by right clicking and zoom in by left clicking, or not. Apparently it's, oh sorry, we put -0, that doesn't work. So inside of map in zoom in, make sure you put -1 and not -0 like me. So M, zoom out, zoom in. We can only go so far, we can only go so close. And let's move on to the next step. That's all done for the zoom. So next let's do the panning. So this is for the movement of the map. So pan map, we'll call it. Now for pan map, we do need to make one little input here because we need to know what direction we're trying to move. So we're going to make this a 2D vector because by default the inputs from our player or our WASD are considered a 2D vector. So we need the input to be just that. So let's just call it from here so you can see. We'll get our move IA because we're using the parent one from the player controller. And so here we're going to do the same thing as map, get it, check if it's valid. If it is, we'll call pan map. And pan map takes in the input of the action value right here. So to see if this is working correctly, let's just print. And to avoid it printing 100 messages and being unreadable, we'll just give it a key so it sticks to one thing. So this is just move. We'll call it a key. Any key works. So now if we press M, if we press W, we go forward. So Y is equal to 1. If we go back, Y is equal to -1. If we go right, X is 1. If we go left, X is -1. So that's how the input works. Obviously, if we press 2 at the same time, we'll do both of them. So let's get to the actual panning. So for the panning, we need to do a bit of math because we need to convert some stuff over from local to world and then back to local. So to do that, we'll start with our input. So we'll get our input all the way at the bottom here. And we're going to multiply it by a speed because obviously by default, it's going to be 1 every time. But in this case, it's more interesting to actually have a certain speed. So we'll say promote to a variable. We'll call it pan speed. Now in my case, I put it by default to 0.2. Now if you want to change this to go faster or slower, that's perfectly fine. It'll work just the same. So with this, what we need to do is we need to tell it what is forward, what is left, what is right. So to do that, what we'll do, instead of just saying, well, hey, if X is 1, we'll just move it forwards on the local axis. What we'll do instead is tell it to take the player camera direction. So based on where we're moving around in the map and looking, we will tell it, well, hey, that's forward. Use the camera for the forward. So to do that, we need to get our camera here. We want to get our right vector, which automatically does this in world space. And then we want to do the same thing, but for the forward vector. Line these two up. And we want to split the return value here because we want them separate, the X and the Y. And so X is going to be times the right vector, and Y is going to be times the actual, Y is going to be times the forward. So we then want to add these two up, because obviously if we're pressing left and forward at the same time, we need to move left and forward, not just one. But when we do this, we need to actually split it, because we can't take in the Z, because if we're facing downwards, we don't want to go downwards. We have a zoom for that. And we're later going to have a level system that works similarly. So we don't want to do anything with the Z. So what we'll do is we will do a plus here. But we're going to be needing, actually first before we do that, to make it more readable, we want to get our map here because we need to do it relative to where the map currently is. So we're going to get our location for the map. And we're going to add the new offset that we're trying to give it to this value. So we want to split this because we only want the X and the Y. Now let's go like this. Now, although this is worth noting, even though it's not very important, this only works if you're using a basic world with Z being the height. If you have anything else, then this won't work the same, obviously. Then we need to convert this from world to local. So we're going to get actor transform, and we're going to transform location, and we want to select inverse because it is from world space to local space, which takes location. Line these up. And then what we want to do, one last thing for the pan, is we want to clamp these values. So we're going to break this because we want to make sure that the player can't go too far off the map, visually at least, because that'd be strange. So to do that, we need to get here a clamp value. And the reason we do it this way and not a basic clamp on the vector is because, well, the vector could do it, but the map, as you can see currently, isn't exactly square, meaning that this length and that length is not going to be the same. So we need to take that into account. In my case, what we have for the X is -90 to 90. And for the Y, we have -20 to 40. And so with that, we want to make our vector, put the X, put the Y, and for the Z, we keep the Z here, because this one is how we're moving it, but this one is just where it is. So we need to make sure we keep the Z. And so with that, we want to say set location, and make sure we use relative location here, because we actually went through the effort of getting the actor transform and inverting it. So it'll work locally. So let's plug that in. And now normally if we go and press M, if we press W, the map moves. And obviously now we can't move the mouse, so it's just gonna have to go forwards. It stops right there. If we keep going a bit further back, we'll do the same thing. There we go, it will stop soon. And right there. Same thing, obviously, if we go right, it'll stop a bit quicker. There we go. Same for left. There we go. So now we can actually move through our map. Obviously, if we want to go faster, we can change the value. So next we can move on to our orbiting. So meaning moving the mouse and moving around the thing. So orbit is what we'll call that. And it also needs an input of the same type. So 2D vector again, call it input. And once again, I'm not going to show you how this works again because we did that before. So we want to get our input here. Make sure you get it from the bottom. We want to split it. And we're going to multiply these by 2 and -2 on the Y. So this is obviously up to whatever you want, but I liked it inverse. It felt more natural. And so what we want is we need to get our spring arm here, get the relative rotation, and we're going to be adding these together, let's say. So we need to break our rotator, and we will be leaving the roll as it is. So we're going to make rotator here. The roll we don't touch, but for the Y, we're going to add the Y here, and for the Z, we're going to add the X. So let me just line these up a bit better. There we go. Or maybe not like that, like that. Now one thing we do want to do for the actual rotation here is we want to make sure that our pitch is limited. For the Y, the yaw, it means turning 180 on ourselves, going around the map 100% is not a problem. We want that to be okay, but we don't want to be able to go under the map visually, just stay above. So to do that, we want to clamp our angle here. And the minimum degrees we want is -60 and the max is -20. And the reason for this is if we go and select our spring arm here and we put 20, that's below. So I'm not sure why it's like that, but that's what it is. -20 is here and -60 is up here. So we don't want to go above that and we don't want to go below this. So we can leave this as it is because we're going to be clamping it later. So orbit, plug into the Y. And then we want to plug it in for the actual Z. We want to just simply plug it in right here. Sorry, there we go. And to finish off, we get a reference to our spring arm. We say set relative rotation, plug it in here, and we are done with the ability to move around, or at least move the camera around. first we still need to call it here. So we want to look for the actual look IA. Call that here. Copy our validated get, and this time we want to call the orbit function. And the input is going to be our action value again, because the mouse can only move in 2 axes. If we go and play now, we can actually pan or orbit around the actual location. If we move, the map moves. It moves relative to our location. I'm pressing forwards here. Obviously now we can only go to the right because it's already too far. And obviously the same thing if we move around like this, no problem. Now if you prefer, obviously for the movement, you can tell it to only move on the X and Y simply. It's a lot easier, but I prefer it like this, so that's what we're going to do. Next, if you get lost in your map, you need to know how to recenter. So to do that, we're going to focus on the actual player itself. And that's going to be a bit more math again, but it's better to have it focus on the player than just center, because then you lose sight of your player. Actually, I say it's a lot of math, but it's actually pretty simple. So we're going to make a new function called focus. This focus is going to simply say get our... No, we don't want to get our spring arm actually. We want to get our map, because we want to move our map back to its location of the player, because otherwise we end up with an issue. If we move the spring arm to the map, then we'll start moving the map around the environment, which we don't want. So we want to here say set relative location, and we're going to calculate that in a second. So it's actually a lot easier than I thought, or at least than I remembered. We want to get world transform. And what this does is we get our transform for the actual map, and we're going to get the location of our player relative to that map. So we're going to get world location, and we're then going to invert the transform. So then we know exactly where our player is relative to our map. So we inverse transform location, and with that, we simply need to apply a -1 on all the axes, so convert to float, -1, and instead of now having the location of the map relative to the player, or the player relative to the map, we'll have the map relative to the player. So we call that location, and it will recenter the map how it needs to be. So back in our player, we want to call IA focus, place it here, get another reference to the map, but this time, sorry, not on trigger, we want this to be on started, because we don't want to do it once. We want to call focus, and compile and save. And if we go and press M, move around, and press middle mouse button, we refocus on our static mesh for the player. Let's go a bit further off so it's very obvious. Middle mouse, we end up at the same spot. It keeps our rotation. If we go like this, we'll still be looking at the same direction. And we can close that. The last functions are the actual moving up and moving down of the level on the map. So let's go and set those up. So we're going to call level up and level, well, we'll just call it actually change level. And we'll just have a Boolean input to say whether we're going up or down. So level up, we'll call it simply Boolean. And so to change this, what we actually need to do is we need a smaller function first, but we'll get to that in a second. We'll just go start with this. So the first thing is we need to do this with the spring arm. The spring arm is the thing that we're moving. So we're going to say set relative location. Plug it in here. And the first thing we need to do is we need to actually know how we are changing our level. So to do that, we need an actual array. And so this is going to be different levels. And it's going to be very simple. It's going to be floats in an array. And the first one will be 0 and the second one will be -30. And this is just a means to tell the player how far the camera needs, or how, not tell the player, but tell the controller how far the camera needs to go down once we tell it to change level. So obviously this will be dependent on what your map looks like. In our case, this is what I tested and it's pretty good, or at least it functions as intended. So to do that, we need to get our spring arm here, spring arm, and we're going to actually use its get relative location, and we're going to use that as a base to tell it how to move. So we want to split this, and we're going to tell it, well, hey, can we find in our array the actual different level? Because we're going to be telling it, and this is where I made a little mistake earlier, is if we focus our player currently and he's on, let's say in our scenario, if he is down here, he's not at minus 30, but he's not at 0 either. So it's a bit of an issue, so we need to bind this to make sure that it's always set to our different levels. So we're going to do that in a second, but first, we'll just set this. So if we do find it, we need to have a +1 and a -1, depending on whether we actually do level up. So this is going to be -1 here. Make sure we actually set the 1 this time. There we go. And we'll do a select int, and we want to get our level up here. And if it is, so if we are leveling up, then we need to use A. If not, we use B. Now we need to make sure that we clamp this, because otherwise we end up with a value above what we can have. And so to get that, we want our different levels. We want to get last index, sorry, not get last index. And we're going to plug that into the max value. Then with this new max value, we once again get our reference to our array. We say get, copy, plug in our new index, and we can split our location, plug in the Z because that's the new height, and for the spring arm we can get our relative location, get the X, get the Y, plug it all in, and now if we go into compile, we go back into our player, we get our level IA, we get level up, we get level down, why can I not call it IA level down, there we go. And with both of these, once again, get a reference to is valid, plug into started this time, both of them, and we call change level, plug it in right here, there we go, both of these in. Now on up, level up, tick the box, and now if we go and play and we press M for our map and Q, we go down. If we press E, we go back up, Q back down, we can't go any further. E again once, and it brings us back to the top. So obviously, as I said, if the player is down in the bottom right here, we won't actually be able to tell it to do that correctly, so we need to do that next. So to fix that, what we need to do is we need a small little function which is going to round the value of an integer or of a float down to its actual correct Z. So we're going to make a new function which we'll call round to closest level. So this takes in an input of type float, which is we'll call input, and it takes in an output also of type float, which we'll call output. Now the output needs to be a local variable, which we'll call L return, and then we're going to have to do a for each loop through the different variables, obviously, because if currently we have 2, so we could do if it's 1 or 0 or 0 or 1, but for sakes of it scaling up in the event somebody wants to use this later, we'll do it this way. So what we do is we get this and we want to subtract our input. So get input again. Sorry, let's get input here, plug it into the top, and we want to see the distance. So if input minus the actual current value of the array in absolute, because you don't care if it's positive or negative, we want to know which one it is, which one's the longest. We want to do, if it is less than the actual value here, which we're going to call the difference, because the difference and the return value are not the same, so we need to make sure that they're separate. So if our absolute is inferior, we don't do anything. If the difference is, if the input minus the current value is inferior to the actual difference, then we can tell it that this is new, that there's a new difference. So set difference here to true, plug this all in, just align that up. And in that case, our return becomes the actual value that we're trying to subtract here. So you can reroute just to make it more readable. There we go. And on return and on completed, we obviously return the value. Now by default, we can leave the difference at 0. That way, as long as if it's double equal to the item itself, it won't change. So that's good. So also, I completely forgot, we can turn this to a pure cast, and we can now go and set it up in our focus. So, okay, so I made a little mistake, just found it. In the L difference, we actually need to put it to 99 or 999, just a big value, because otherwise it'll never actually be below 0, because unless it's perfectly on the dot, it won't work. So it will always set itself to the return being 0. So we need to do that first, but then there's also another issue in the chain, or the focus, sorry. If we focus, let's say I tested by putting the point at the bottom here. If we try and focus that, it's going to actually put us here. But if we go down, we end up below what we actually want. We don't want this to happen. So to solve that, we need to tell it, well, hey, we're moving down this low, so we need to know that, and we're going to tell it how to handle it. We're going to tell it, well, if we go that low, we need to actually tell it, hey, well, the spring arm can be that low. We don't need to move anything else. So to do that, we will break this actually here. And we're going to detach this. And we want to make the new location without the actual Z. So leave it always as 0. And we will use the Z to actually set the camera. So we put it to -1 here, because we would want to use this normally. So -1. And then we want to say round to closest level. And with this closest level now, we will know the relative height. So we get our spring arm, we say set relative location, plug it here, and we can then split this. And we want to get relative location, split that as well. And we just want to plug in the X and the Y to keep that location. But we want to plug in the new Z right here. So now, with our player still at the bottom here, if we focus normally, we should end up right here at the lowest level correctly without able to go below. And if we go up, we end up again at the right level. So that works correctly now. So with that, we do have all our functions set up, but there's still some extra functionality we can add, like telling the player where he is once we open it for the first time, because currently we just set the camera, but we can do a bit more than that. So in our event graph, next what we need to do is we're going to use our actual spawn that we made earlier, where we told it to have a tag called spawn tag. So I probably should have done this now. So for those who haven't done it, on the player start, look for tag and set its tags to spawn tag. And in a map, we want to get all actors with that tag, specifically we're looking for the only one, and we paste it. And just to be sure, in case we get a copy of the first one, we get actor transform, and we're going to promote this to a variable because it's easy to use. We're going to promote this to map origin, we'll call it, or maybe player pivot, we'll call it. And so there's also one other thing we need, is we need to know how the player map here, so the one that we have in our viewport, scales relative to the real one, because that's something very important. We can't really get it too easily. So just simply putting a value in, because we'll know, normally you would know the scale of your map relative to your mini map. This is 1. This is, if we select the map, 40. So we know our scale is 40. So we'll call our scale here. And the scale will be 40, or 1 divided by 40. So 0.025. So the next thing we need to do is we actually take that into account. So one other thing we do need to do is we need to set our pivot to the relative location to our real world pivot. So to do that, simply copy this, or maybe actually put these two correct full values, it'll be easier. So set these to these values, whatever it is for you, it's fine as well. Just copy them, paste them on the pivot. So although this will be absurdly far, we then want to divide by 40, because that's how it is relative to this map. So now if we look, it appears in about what you would expect the same location to be, right here. So with that in place, we can now go and tell with our pivot the different things we need to do. So we want to get player character. We want to get actor location. And with our map or with our player pivot, we're then going to say inverse transform location, which will take it from world to local of the actual player. And what we want to do then is we want to multiply it by the scale. So we want to get our scale right here, plug it in right there. And with this, we can then get our player and set its relative location. As this puts it in relative, but still it'd be too large. So we need to then decide, well, hey, the scale is 40. So just like what we did with our pivot here, we get the world location, we divide it by 40, or in this case, we multiply it by 1 divided by 40, which is the same thing. Plug this in, and now if we go and play, we can move around. And if we go and let's say we'll stand here, if we look at the map, the player is right there. If we focus it, that's where the player is, and that's where we are standing as well. But we can also add the rotation to that. So we'll do a very similar trick, copy our player character, get rotation, actor rotation, sorry. And we will get our pivot as well. We will say get inverse transform rotation, but this time because it's rotation we don't need to divide it or anything, but we do want to just make it so that we only take the actual yaw into account. So get player, set relative rotation, split the struct, and just simply plug in the yaw, plug this in here. And one extra thing we can do just to make sure, just to make it nice, we'll just call focus here so that the player automatically is attached, or that the map is automatically focused on where the player is to start. So if we press M, as you can see, we're focused where we need to be. We can still pan, we can zoom in, zoom out, we can change level. If we go and open the map when we're on the bottom floor here, so let's go and try that out, see what happens. If we do that, we should normally have an adjustment to it right here, so it knows we're below. If you press Q, we can't go lower, but if you press E, we can go back to the next floor. And I believe that is everything. We can still zoom in, we can focus it right here, zoom back out, move up a floor, etc. No problem whatsoever. Move the map. We can't go much further than this because that's the limit, but we can go all the way back the other side if we want to. So one last thing I want to check before saying goodbye, just in case. Okay, so I'm not exactly sure why this is, but there's a bit of an issue with the character for some reason, where by default I can't move my camera. So I'm not sure if this is happening with everybody else, but on my personal project this doesn't happen. But just in the event that this is happening for you, I'll give a solution, because it's a very strange bug I've never seen before. So normally it probably would be better to, instead of having this like this, have it in an actual actor component, let's say, attached to the first person character instead of creating a child. But just because this is how it is for now, we're just going to do a solution here. We're going to go into our character that we made based on the first person character. In the first person character, we will copy our actual inputs here. We'll detach the triggered, compile and save, and we will paste it here. And we're simply going to call it on the is not valid, because that's what we want to call it. And to do that, we just want to break our action value here, plug the X and the Y like this, compile and save. And now normally, if all is correct, we can move our camera again. If we press M, everything works as intended, no problem there. M again, if we look this way, the arrow is pointing that way. So it's working once again. I hope this fixed, if you had this issue, I hope it fixed the issue. Thank you for watching. I hope you enjoyed the tutorial, and I will see you in the next video. Goodbye.